use your chat window, try to describe what is this picture is about. So let's see who is going to describe this picture beautifully and try to extract some of the objects that you see in this particular picture. So what do you find in this particular picture? So go ahead and describe it in your chat window. So then I will answer, then I will ask questions basically, right? Yep, so here we go. So we have the question from Pratik says, okay, dogs, perfect. Ajit says dog lover. So Narendra says entitled analysis, dog, human, identification. Okay, so Pratik again says image classification. That's awesome. So we don't have to go for the much complex things. Okay, so let's be more simple. Sumit says number of dogs and number of peoples. That's awesome, right? So Piyush says some paintings. Okay, that's awesome. Naveen says peoples are relaxing in garden, right? So people chill in a park with their pets and friends. What an awesome description. I love it, Joseph. Perfect. So Ramesh says a dark park with the white dogs with all owners. That's awesome. Good. We know that. So we are super intelligent. We could able to describe this particular picture, right? Isn't it? Perfect. But that's not my question. No, that's not my question, folks. Okay, let me just go ahead and ask my real question. Okay, let me ask my real question. How do you know this is a picture of a park? You said this is a beautiful picture of a park. You can see there are a lot of dogs. Yep, I can see there are a lot of dogs here. How do you know this is a picture of a dog? So who taught you this is how the dog looks like, right? And how do you know this is a picture of a trees and you can see there is a men and you can see there's a women? Perfect. Yes. Yeah, we know that. But how do you know that is the question? The question is, how do you know this? Who taught you? This is how the dog looks like. Why can't this be a cat? Right? So Divya says a la. Sandhya says a label data. That's an awesome answer, Sandhya. Perfect. But let's keep it more simple. What if I go ahead and take the same exact picture, okay? I will go ahead and take the same exact picture to this newborn baby, and maybe a baby is less than 1 year old. So do you think a baby could able to recognize the same exact things that you could able to recognize? Can a baby describe this is a picture of a park, this is a picture of a dog? No, right? But barely a newborn baby could able to recognize maybe a mother and a father, but apart from that, a baby doesn't know anything else, right? So what I'm trying to mention here, so we are a biological machines, there's no doubt about it. And so obviously, let's say the way we learn the data in different ways, right? So obviously a baby born with an empty brain, logically it's not empty, but let's say it doesn't have any sense of an environment. But a baby started learning from his in mother womb, maybe, yeah, or maybe starting from his birth, right? So consider that baby learns how to recognize his father, mother, right? So baby started, let's say, learning how to walk. So, but what if I go ahead and display the same exact picture, maybe a bit of a grown-up kid here, right? This kid could able to describe this picture in a much better way, right? Than, let's say, a baby couldn't, but maybe this grown-up kid could able to recognize. Maybe it says, okay, let's say, how does this grown-up kid might recognize? I love to play with this park. I love to play with my dogs over there. That's what exactly you might say. But what if I go ahead and display the same exact picture, maybe a grown-up adult, maybe for you, right? He might describe it in much better way. That's what exactly you are describing it in the chat window. You say it's a beautiful picture of a park where I can spend my entire day over there, right? Isn't it? So with the beautiful dogs, with your friends, maybe with your family. So you can see the way you describe varies. So that's basically the knowledge that you have gained, right? So we are the biological machines. And what we today talk about AI, so artificial intelligence, it's nothing but today, human beings are trying to replicate on human beings, right? So we are trying to create an AI. It's a clone of ourselves. So obviously, there's a different stages over there, but consider that it's all about data, right, that we're talking about. So consider that as a human beings, we consume a data in many different ways, isn't it? Just remember that, how you consume a data. So consider that you consume a data through your eyes, right? You're currently seeing my slides. You're consuming my audio. That's another way of you consuming the data. And obviously by touching things, by feeling things, you can consume a data. And you can consume a data through your nose, isn't it? I can smell the food. I can smell the favorite biryani. I could able to recognize whether it's a Hyderabad biryani or a Delhi biryani, right? So as a human beings, we consume a data in many different ways, and we learn this data, and eventually we get better and better in that, right? If I put the entire growth cycle of a human beings, every day we exponentially keep on learning, and we eventually get better in that. And finally we expire, but that's a topic for different day. But yeah, so this is basically, we are the best examples of what we today calling it as an AI. Basically, human beings are trying to replicate and human beings, right? Through this dumb machines. Yes. hardly, there's this machines could able to understand zeros and ones. That's it, right? So we are trying to replicate the same thing, what we could able to learn and way we could able to make a decision, because you have learned so much, you can able to make a decision. So let me tell you, what's the best decision that you made today? Yes, attending this demo session, definitely. So you have made a decision. And again, so obviously it's drived you to this particular program. It's a one of a reason. Maybe AI is everywhere and you have a goal of, and you want to be part of this particular AI industry, right? So you could able to make a decision based on what you're learning already, right? So we are trying to replicate the same exact things with these machines. So this machines doesn't know anything else. And we started teaching the same data that we have learned to these machines, right? So let's throw a simple example here. Why not, right? So consider that I have a document, okay? Let's assume I have a document. Let's say it can be a CSV file, okay? So let's assume, so you have the CSV file, what data, this date, in this CSV file, I could have any data, doesn't matter. But consider that we'll pick a different use case, okay? Let's say I have collected a lot of electricity data from your home. I mean, the amount of electricity that your electrical appliances that consumes, how much energy your washing machine, water geyser, air conditioning unit, etc., any other electrical appliances that you do have. So I have collected all this data, the amount of voltage, amount of current it consumes, and the bills that you might have paid for last 3 years. Let's assume it's a 3 years old of data, and I have around 30,000 data points. So I mean, this is a CSV file, I have 30,000 rows in it. My goal is pretty much simple. I want to take this data, I want to teach this data to a machine. A machine can be a server in a cloud, it can be your own personal computer, and it can be edge devices like this, right? So what we call it as machine learning. We go ahead and teach this data to a machine, right? So what happens, this machine tries to understand the data, it tries to understand the pattern from the data. So what do you mean by pattern? Let's consider that we are talking about an electricity consumption data. Let's say machine understands how much electricity that you consume maybe in summer, how much electricity that you consume in monsoon, right, in a spring, etc., in various different seasons in winter. So it tries to understand, right, and basically it produces something called machine learning model. Right? A model, right? I'm not talking about fashion model. No, I'm talking about a machine learning model. Just remember that it's like a brain which knows everything about your data, right? So let's say I'm talking about a machine learning model, and this is the model which will be part of final end product. Okay, so this is part of final end product, but this is not final end product. This is going to be part of final end product. But what exactly we can do with this model? So let's say I can go ahead and ask a simple question to this model. So tell me, what will be my electricity bills going to look like for the next 6 months? So I'm going to ask a simple question, right? I want it to predict, so what will be my first month bill? What's my second month bill? Blah, blah, blah. What's my 6 months bill going to look like? So what exact amount of electricity bills that I'm going to pay? So it can be a very simple use case. I'm asking it to predict the future, right? Or we'll throw a different use case again. So let's say instead of I'm taking a CSV file where I have a document, let's say I will take a bunch of pictures of cats and bunch of pictures of dogs. Okay. So I'm going to teach the difference between a dog and a cat. Let's say I'm talking about pictures, videos, anything that we can do with images and videos, right? We call it as computer vision, right? So again, machine learns the difference between a cat and dog, and again, a machine produces a machine learning model. So what we can do, let's say I will do something like this. Let's say I will go ahead and put a camera in front of my model, and I will be putting a cat maybe in front of my camera. So then my machine is going to predict, okay, there's a cat in front of your camera. So what we're talking about, an object detection, right? Your model could able to recognize an object, which is a cat. It's exactly what you've done in this picture, right? You could recognize that's a picture of a dog, there's a picture of a park, something like that, right? Or we are talking about today, a large language models are, putting in a very simple terms, generative AI, right? So let's say we're talking about, there's a huge data that's available in the internet, right? So for a reason, we call it as LLMs, large language models. Just remember that organizations like OpenAI, who made ChatGPT, or organizations like Meta, or AWS, or any other Anthropic, Claude, those organizations might have scrapped the complete internet from the data from the internet. They might have built what we call it as a large language models. That's why it's called large, because it's really large. So, and again, today what we're talking about, this generative AI, for a reason we call it as generative. What does that mean? This generative AI models can generate a content which never exists. For an example, a text to text. If you input a text, it generates a text, correct? So let's say if you go ahead and ask a question to your large language models, right? Can you write the beautiful bedtime story for my kids? It does the job. And can you write the code for my application? It does writes the code for your application. And where we get a fear, okay, it's going to replace me as a developer. Actually not, but yeah. So otherwise we are talking about other kind of a models. Text to image. If you input a text, it can generate an image. Text to video, it can generate a video. Text to audio, it can generate an audio. There are different kind of use cases, right? So all falls in the industry called AI and artificial intelligence. Good, we got it. We got it where we are heading towards today. Yes, good. But where does MLOps really fits in? So what is exactly MLOps and how can be really benefited for you, right? So let's get into that. So let's now talk about a typical workflow of creating a successful machine learning model. I'm not talking about a complete end-to-end automation or something like that. I'm talking about what's the minimal prerequisites for any organization to build a successful machine learning model. It can be classical machine learning models, large language models, or Gen AI models that we're talking about, right? So let's say the journey starts from the data, correct? Data. So consider that as a human beings, we consume a data in many different ways. A machine can also consume a data in many different ways. So your data can be a picture, JPEG. Your data can be in the form of CSV file. It can be a JSON document, text document, or even more, right? Your machine can also consume a data in many different ways. Perfect. Then what is the next step? So once we have a raw data that is coming from your customers for your use cases, the first step here comes someone called data engineers or data scientists. They do something called data preparation. So what do you mean by data preparation? So data preparation is something similar to what we do in our kitchen. Yes, exactly. So, I mean, let's say if you want to prepare your favorite food, right? Maybe if you want to prepare your favorite recipe of a food, it can be anything. Let's say maybe I want to cook a biryani. Why not? So what I do first, I go to the market, I go ahead and buy all the ingredients, the masalas, vegetables, etc. Correct? Chicken, yeah, or mutton, who knows? Yeah, whatever it is. Meat, I buy. So then I come back to my home, I started cleaning my vegetables, some meat, etc. Then I put an oil, then I put an ingredients, I started cooking, right? Here we go, the biryani is ready. Exactly, right? Yeah, that's what exactly we do in a data preparation. So what happens, the raw data that is coming from a market, right? I mean, from your customers, which has a lot of garbages in it. Data can be messy. Your data might have some missing values in it. Your data might be incomplete. There might be something called outliers. So what data scientist does, our data engineers, they clean and prepare and they transform the data if necessary. So they clean the data. That's what exactly we do in data preparation step. So then comes the next step in a workflow is experimentation. So we have a data that is ready, but what is the game that we are playing? Taking the data, teaching the data to a machine. Perfect. Good. We got it. So now let's talk about experimentation. So who builds the model? Who makes the model? Someone called data scientist. Yes, he makes the model. So here comes the things. Let's say you want to train a model and he has a data in a previous step. So this is where he will be using an IDEs like Jupyter Notebooks or VS Code, whatever the IDE it is, where he can go ahead and write some code. It can be Python, whatever it is, whatever the programming language you want to use. And why we need to write the code here? Because you need to pick the right kind of a data, isn't it? So where is your data is coming from? Whether it is coming from your, what? Is that coming from your kitchen? Whether it's coming from a bedroom? Okay, logically, let's say where have you stored? Have you stored in a database? Where it is? Which storage platform? So we need to specify, right? That's why we use Python to specify. And again, the game is all about taking a data, teaching the data to a machine. What is a machine? A machine can be a CPU, a machine can be a GPU based machines, right? We need to specify what kind of a machine it is, right? He specifies that in the code, right? And then comes, he need to pick an algorithm, a software which can help him to train this data to the machine. So he picks everything and he runs the code, and that's where your data will be started feeding to the machine and it will start learning. So then it produces something called machine learning model, obviously. But here is a problem. Do you know why we call data scientist as a data scientist? Because scientists are someone who does an experiments, correct? So a data scientist, most of the time, he cannot come up with the best quality model because he does something called experiments. He does experiments again and again. He does the experiment different times, iteration 1, iteration 2, iteration 3, until he gets the best quality model. Let's assume maybe after a couple of trials, he got the best quality model. Let's assume it's a first version of a model that he has produced. First version of a model. Okay, now let's talk about something called model registries. Okay, so what do you mean by model registries? Okay, let's talk about a software a bit. Let's say you might be using a various different softwares, a WhatsApp, a Slack, or maybe Microsoft Teams, etc. Right? Tell me, are you using the first version of a software they ever produced? Are you using the latest version? Definitely, we are using latest version of software, right? So the same thing applies for your AI. So AI models as a version. Throughout the life cycle of your AI project, your data scientist will produce multiple different versions of a model. Then what kind of a tool that we can use to version these models? We call it as model registries. We will discuss in detail later. So here we will be using a specific model registry. Maybe if I want to name a tool, I will call it as ML flow. So which you can able to use it to version different versions of models, version 1, version 2, version N. Perfect. So let's assume now you have a first version of a model registered in a model registry. What is next? Now we talk about deployment. So now we need to go ahead and deploy this model to the production. It's similar to how we host a website, correct? So consider that you have a website. You go to www.google.com. No, let's say www.siteontech.com maybe. So you know our website, right? You know our website over there. But how does this website has been hosted? Yes, we put the code on a server. That's how it works, right? In the same way, we want to host a model. You can host a model in many different ways. Many organizations, they follow different strategies. So consider that here, let's say I want to Dockerize my machine learning model. I want to go ahead and deploy into Docker platform. And let's say there might be an organization who want to deploy the model to something called Kubernetes. And they want to deploy to something called real-time endpoint, a batch, serverless deployment. There are different ways to deploy the model to the production. Okay, so now let's assume you have deployed the first version of model. Then comes what? Okay, here comes obviously our dear developers who builds beautiful apps, web applications and Android applications, a way you can go ahead and use your application. You know, ChatGPT, right, is a product. So basically you use a ChatGPT UI to invoke a model, right? That's what exactly I'm talking about, right? So this could be the typical workflow of creating any successful machine learning model actually. Okay, so we do understand what is machine learning, right? So machine learning is all about study of an algorithm, or mathematical models. So where your computer keeps on increasing progressively on that. It's all about teaching complex mathematical models to the machine folks. And once machine understands a math, it can go ahead and help you to make predictions, decisions, whatever you want. And again, as we're talking about programming languages, here comes your data scientist, someone who makes the model, not the MLOps engineers. Your data scientist uses programming languages like Python, R, C++, right? We can use various different languages to get the model. And the question is, who builds this kind of an automation? So this is the complete automation that we're talking about. So this automation is something will be built by who we call it as MLOps engineers. So let's go ahead and explore both. But still, the question is what exactly the MLOps is all about, right? So what is MLOps? Right? So let's go ahead and explore MLOps right now. The first point. So now before we go ahead and explore what is MLOps, now let's try to understand the state of machine learning across the globe, across the universe otherwise. Okay, so what do you mean by the state of machine learning? So obviously there is always a word called time to market, correct? Right? So consider that everyone who goes to the market first, they used to eat the bigger piece of cake. Obviously, someone who goes pretty much late with a lot of competition, they get a smaller piece of cake, right? So that's how it's going to happen. So let's say what I'm trying to mention here. So what's happening in every organization today in terms of machine learning? So let's go back to last 10 years ago. Can we do a time travel? Yeah, let's go. Let's go to the time travel ship and let's go for last decade. So let's say I'm talking about maybe last 10 years ago, probably, right? Last 10 to 14 years back. So let's say every organization at that time, every software industries at that time, they had a lot of data sitting in their organization, isn't it? And they're doing nothing with that data. So, but that's the time where they started hiring for someone called data scientist and data engineers, etc. Someone who can able to build a machine learning models. So the only focus for organizations last 10 years ago, they're building models. They're playing with it. They're trying to experiment what they can do with that. They have no idea whether we can make some money out of it. So, but they're not operationalizing. So operationalizing is not at all a plan. What do you mean by operationalizing? Deploying the models, and making some money with it, right? Reaching your customers. That's not happening. But if we talk about today, right? Almost, if we talk about up to date today, beginning of this particular year, you will see almost 53% of organizations who have POCs now they have started making it to production. So that means, and it takes an average for any company for 9 months to get started with and completing the operational part here. And you can expect by end of 2025, almost 75% or 75 plus percentage of organizations will shift from piloting to operationalization. Okay, good. That's good news, but what's that for you, right? So how is that really helping for you? So let's say here we are talking about an organization who's building a model last 10 years ago, they're not operationalizing. But what it takes for any organizations to operationalize their machine learning models. It can be any classical machine learning models or large language or Gen AI models, any kind of a machine learning model that I'm talking about. So this is where an MLOps comes into the picture. MLOps is all about basically, let's say, it's all about building an automation to end-to-end automation to deliver your AI to the production. So MLOps is all about the practice for collaboration and communication between various different stakeholders who are part of building an AI project. So, I mean, consider that when we're talking about different professionals who is part of building an AI project, there are data engineers, there are data scientists, there are ML engineers, there are MLOps engineers, there are senior folks, senior data scientists, senior MLOps engineer, MLOps architects, etc. The collaboration and communication between them, what we call it as MLOps. So basically MLOps is all about, let's say, building an automation, right? When you're building such kind of an automation, it can able to increase the quality and simplify the management process of how an organization builds a model, delivers a model to the production. So when I'm talking about MLOps, as I mentioned, it's all about an automation. So you learn an automation here to deliver your AI to the production, right? Automating your machine learning or deep learning models to the production, to the large scale production environment. So deep learning models, which are nothing but all this deep learning based generative AI models to the production. So saying that, so now let's go ahead and try to understand the MLOps motivation in a high level view. Okay, so when we're talking about MLOps as a discipline that sits intersection with various different domains within an organization. Obviously, when I'm talking about MLOps, it's an intersection between a machine learning, DevOps, data engineering, and what we get, MLOps. So let's say when this intersection of these practices, when they are coming together, they really drive a value for any organization and how they build, deliver, and manage their machine learning models to the production. But good, we do understand MLOps is all about automation, but without having a solid set of people's process and technology in your organization, MLOps discipline cannot be implemented in any organization. So it's also, you need to have a right set of people's process and technology. What we're talking about are tools, right? Yeah. Saying that, so now we do understand that. Now let's focus on the challenges here. Can we? Perfect. So when I'm talking about MLOps challenges, right? So let's say in the process of, let's say we are creating and managing a machine learning workflows, definitely any organization will run into a lot of different challenges here. So consider that, I'm sorry, let's say consider that. So we do have 3 different steps to get started, right? So let's say one is data preparation step, model training step, and model deployment step, okay? So what do you mean by that? So let's get started one by one. Let's get started with data pre-processing step, right? So what we do in a data pre-processing or data preparation step. So in a data preparation step, let's say you might contain one to many tasks. Like for an example, you want to take a raw data from your customers and you eventually want to transform that data into, let's say, training data, test data. See what happens when you train your machine with your data. You don't train every data that you do have. You split into 2 chunks. You keep huge chunk for training and we keep a smaller chunk for testing. See what happens. You might be having a kids. Let's say your kids go to the school and how a school will evaluate your kids. They provide an examination, right? Yes, that's what exactly we do. We take a huger piece of data, we train the machine and we keep the smaller piece of data to test whether the machine is really working, whether it's making a solid predictions that you need. Okay, so then comes, we are talking about, let's say the next step in a workflow, we are talking about model training. So what we do in a model training step. So in a model training step, you might have some additional steps inside your model training. So whether you're doing single model training, whether you're doing hyperparameter optimization. So what do you mean by that? Hyperparameter optimization. It's all about the experiment. I did mention that. Data scientist is someone who does an experiment. He does these experiments again and again to figure out the best model, right? So consider that maybe he builds different versions of model, version 1, version 2, version 3. Maybe he decides, okay, version 3 is the good, and now I want to go ahead and deploy this version 3 to the production. So then comes, we are talking about a model deployment step. So in a model deployment step, you might have only one step in a workflow, or it could have many steps underneath it. So consider that here, okay, let's assume you have first version of a model. Okay, can we go ahead and deploy this model to the production, the version 1, all done, the job is done? No, that's not how it works. So consider that when you have the best model that you have decided, okay, this is a model that can go to the production, you don't directly deploy to the production. So instead, first, you'll be going ahead and deploying to something called a staging environment, right? So what is a staging environment, which is an exact copy of a production, but it's not a production environment. So what you do, first you go ahead and deploy the first version of a model to the staging environment. Okay, it's not a production, then this stage is for whom? Obviously for your internal team. Because your internal team, maybe your MLOps engineers, your data scientists, they go ahead and do the further testing, a thorough testing. Because you want to ensure that how your model is going to work in a production, right? So you test it and you feel it's good, then you go ahead and deploy your model to production environment. So that's how it's going to work. And once you deploy your first version of a model to the production, and this is where your customers comes and use your model, and at the end of the day, they are happy, they pay your money. Yeah. Okay. Saying that, but yeah, so we have a different environments here, but even though we have a different environments, we need an additional control over there. Okay, so now you have a first version of a model. Can I go ahead and directly deploy to the production or staging? No. Instead, let's say I need an approval process. So consider that I might be having some senior MLOps engineer, senior, let's say a data scientist. He goes to the portal where he sees an approval button. So he goes ahead and reviews the results of how your model is really performing. And if he is satisfied, he goes ahead and clicks on the button, he approves it. So that means then the model will go ahead and deploy to the staging and production basically. So that's how it's going to work. So what we're trying to say at the end of the day, so there are a lot of different steps. So there are a lot of different dependencies has to work together to ultimately build this and build out something that provides an iteration across the life cycle and also provide an end-to-end traceability, correct? What we are talking about monitoring. See, consider that when we are trying to build an end-to-end automation in order to deliver your AI to the production, you use a lot of different flavors of tools, infrastructure, and you need to monitor each and every tool here. And again, monitoring the model that you deploy to the production, right? Monitoring also plays a very important role. Yep. So that would be the major challenges. And now let's move on to the another word that we keep on using. So when we say MLOps and we say there is something similar to that, DevOps, isn't it same? We ask, right? Is this DevOps and MLOps, are they same? Definitely not, but there are some similarities here. So consider that the challenges that we discussed, right? The challenges that we discussed in operationalizing any AI model to the production. We have some common things comparing with DevOps. Basically, DevOps is that we use in a traditional software industry for a software production. So DevOps is used for delivering a new version of your software to the production, right? So, and again, in a DevOps practices, we use the CI/CD practices and source version control practices. They are exactly same in MLOps as well. And here we go. A good news for DevOps engineers. Okay, so if you are a DevOps engineer, you have an experience already that you can demonstrate when you're applying for the job. Okay, so saying that, so now let's see what else that we do have in MLOps here. Okay, so we talk about something called source versioning, tracking versioning data, model artifacts, model versioning. What is this is about? So to understand this, why don't we discuss about a beautiful story? Not a bedtime story. I'm not going to let you sleep here. So, but let's discuss a simple story which helps you to understand. So basically how an end-to-end the MLOps would look like, right? Perfect. So saying that, let's get started from here. So let's go back to 2020. Okay, let's go to 2020. So you know what happened in 2020? That's the time the world has been hit by COVID, correct? So consider that. Let's assume in 2020, there is a data scientist, okay? A data scientist is actually building a machine learning model for theater owners, for a movie streaming theater owners that we're talking about, okay? So what is this model? What is the use case? So basically this machine learning model is going to help a specific customer in order to predict how much money they're going to make by selling a tickets in a theater. It's going to help them to predict how much money they can make, right, by selling a tickets. But consider that it's a year 2020 and the data scientist didn't worry about implementing any kind of an MLOps practices. There's no automation. He has built the model manually. He has deployed the model manually. There's no monitoring, etc. But the problem is this particular data scientist assured a client saying that this model is going to perfectly work for next 3 years. That's a problem. But what happened? This model got failed in next couple of months. The reason is COVID, right? See what happens once the COVID hit the market, no one went to theaters. We gradually stopped going for theaters here, right? So we gradually started reducing for going for theaters, right? We didn't immediately stop, we gradually stopped, right? So basically what I'm trying to say here, your customer behavior is changing, correct? People who are going for theaters, now they gradually stop going for theaters. But the model that he designed, it failed, right? Because it couldn't able to understand the changes in the behavior of your customer. Technically, we call it as drift, a data drift. So because he didn't implemented any kind of a monitoring tools, especially to monitor the quality of a model or to monitor the quality of your data, he didn't. So the model got failed. So in case if you could have implemented any tools for monitoring a data, so you could have just understood that, okay, your customer behavior is changing. That means I can go ahead and retrain the model with a new behavior of your customers, because I know that customers are no more going for theaters. So with that, a model could have been updated, but he didn't do it. So this is a one side of a story. But now let's go to another side of a story. Okay. But when we're talking about another side of a story, we are talking about a changes in a customer behavior, correct? So let's say before COVID, we are good, we are going for theaters, but during COVID, we gradually stopped going for theaters. And at the time of lockdown, we didn't go for theaters to watch a movie, correct? We are completely locked down in your home. But you might have noticed we've started watching more movies in lockdown without going for theaters. How? OTTs. So you know that OTT platforms has been skyrocketed at time of COVID. There are new OTTs born at that time. So this is again a changes in customer behavior. And during today, right? Even today, I would say there might be a very small niche of people who might have stopped going for theaters regularly. Because if I wait for next 30 days, I can watch the same movie in my time phase, in my home, right? I can watch it anytime. So that's the changes in behavior of your customer. So that means I'm talking about your customers are your data, isn't it? Correct. So then comes your data has a versions here, isn't it? Before COVID, during COVID, and after COVID, you have 3 different versions of your data, behaviors of your customers. So when we're talking about MLOps, tracking and versioning of data, it plays very important role. That's the first thing. So then comes source code versioning. See, consider that here, MLOps engineers are data scientists. You all write some script. Script doesn't mean just a programming itself. Maybe you work with ML documents, JSON. It can be any script that we're talking about. So the code that you write will keep on changing. Consider that if you are a developer, as someone who writes the script, you tell me how many times the code that you might have written has been changed. Maybe more than 1,000 times, you would say. So this is where the importance of source versioning control tools like GitHub might play a very important role. So then comes, we are talking about model artifact versioning and model versioning. See, we discussed. So throughout any machine learning lifecycle, so we won't produce only one version of a model because we produce various different versions of a model depending on a data. So as we discussed, there's a drift in a data. I train my new model with a new data that is available with me. So then I produce various different versions of models. It can be a machine learning model. At the time of you produce the machine learning model, so you have your own version of machine learning model, and you'll be also having a model artifacts. So model artifacts are metadata that comes along with your model. So consider that each and every time when you train your model, you might be having a different data, different parameters, different settings for training this model. All those things would be called as model artifacts. We'll be also versioning that. So this is what it takes to build a successful automation to deliver an AI to the production. But this data scientist has not implemented any automation. That's the reason which has failed, right? So this is exactly what it takes to build a successful automation here, right? That's what exactly that you will be learning in this particular program. But So we know that, but there's one more problem. So let's say when we're talking about implementing CI/CD practices, you know that the traditional CI/CD tools are not necessarily built for machine learning. So in reality, what will happen in most of the time, there will be a custom built tools. You might be using a custom built tools for data pre-processing, model training, and model deployment. So all these steps that I'm recommended here can be complicated and challenging. So where we want to stitch things together. So I want to stitch things together, right? Source versioning, tracking your data, model artifact versioning, model versioning, etc. But the another common challenges that everyone faces here, there is no a golden pipeline that you can follow here. So what do you mean by a golden pipeline that you can follow here? So today, let's say if I'm going to draft an architecture for your organization, not every organization can follow the same architecture because the requirements for technical implementation for your organizations can be different. Your organization structure can be different. Tools that your organization want to use can be different. Maybe an organization want to use AWS, Azure, maybe some organizations they want to use GCP, or even though you're using cloud platforms, you want to use a lot of open source tools along with that, like Docker, Kubernetes, MLflow, Kubeflow, ZenML, etc. Right? So let's discuss further. So saying that, keeping everything that I mentioned in mind, so now let's start learning how you can able to master in MLOps. Okay, so let's get started. So what it takes to master in MLOps. First, let's try to understand the MLOps components in more detail. So what are the different components that we do have in building a complete automation? So first, we'll be getting started with use case discovery. So any organization, they definitely need to have an access to the data and the proper use case, right? If there's no use case, there's no point of, and there's no proper access to the data, there's no point of talking an AI or generative AI or any machine learning or operations, right? So let's assume any organization, they have a use case. Perfect. What happens next? So then comes a data engineering team. They build data pipelines because first of all, they need to have a data. They extract the data through pipelines, data pipelines. So then comes, we build a machine learning pipelines, an end-to-end machine learning pipelines, where you build an automation to automatically extract the data, clean the data, train the model, and deploy the model. Everything will be automated. So then comes production deployment, and then we go ahead and implement production monitoring. We discussed the importance of monitoring. Monitoring your models only is not the only important step, but you need to monitor the complete infrastructure, right? Okay, so let's dive into one by one. So let's say first is business understanding. So then comes use case identification. They identify the use case and they first understand the data understanding, and they conduct what we call it as a feasibility study. Because any organization who is heading towards getting into AI or building some AI models that can help their customers to solve some problems, first they need to have this feasibility study, and they need to have enough access to data, and they should keep on harvesting a data for your future as well, right? Okay, saying that, so the next step would be data preparation. So we do understand what is data preparation already. It's all about cleaning a data, transforming a data. So then comes picking up the right algorithm. So algorithm, there are many different algorithms that your data scientists would be picking to go ahead and build this machine learning models. And then comes, in the next step, we go ahead and build a model. Basically, we train, right? And then we conduct experiments. As we discussed, a data scientist conducts various different experiments to come up with the best quality model. And then comes a model evaluation step. So what we do in a model evaluation step? How does any organization knows that this is the best model and this is fit to be deployed to the production? So this is where model evaluation step comes into the picture. So testing a model, right? And at end of model evaluation, we extract a metrics. So what do you mean by metrics? As some kind of a numbers that helps your organization based on the benchmarks they have to decide, which gets the confidence for any organization based on the numbers. This is the best model I can go ahead and deploy to the production. So then comes, we're talking about model serving. So where I can go ahead and deploy the model, right? So here I go ahead and deploy the model. As we discussed, deploying the models, every organization, they follow different strategy. I want to deploy it on AWS, Azure, GCP. Maybe Docker, Kubernetes, maybe serverless, IoT devices, lot of options they have, right? So they pick one option, they go ahead and deploy it. And there we have an automation. So where we have an operation, we keep on operating it in a production. And so we have our monitoring tools, which keeps on monitoring the entire infrastructure, and where we have our monitoring tools to monitor the models in a production. We keep on monitor the models. And in case if there is any performance deviation, we monitor this and we optimize it, right? We optimize it by fine tuning with new data. We retrain it with a new data, for an example, right? So this could be the components. Saying that, so now let's head towards a very infinite number of times of important slide. Okay, so let's get started. I'm talking about, so this particular slide will get you a good idea about what an end-to-end and high-level automation in industry would look like. Okay, so we're talking about an automated ML pipelines versus a CI/CD pipelines. So let's get started. Let me have some water. Okay, so let's get started. So today, every organization, they are trying to move from building an automated ML workflows to a complete incorporated CI/CD pipelines. So in automated workflows, there's a straightforward way of implementing an automation. So where we have a data, do the data pre-processing, train the model, then you go ahead and deploy the model. But when it comes to incorporated CI/CD practices, this is where it adds a much better control, a visibility and scalability for any organizations. Okay, so when we're talking about MLOps, in industry, we used to use a term called MLOps maturity level for every organization. See what happens, every organization on a day one, they don't implement complete automation. Let's say we are talking about level 0. Level 0 is no automation. Everything will be done manually. Taking a data, preparing a data, teaching a data to a machine, and taking a model, deploying the model to the production. Everything is done manually. But once you go to level 1, 2, and level 4. Level 4 is what we call it as an highest level of automation. What we call it as an automated retraining pipelines. So here in this particular program, so you'll be exploring this, understanding various different levels of automation and building a highest level of automation to deliver your models to the production. So when I'm talking about a level 4 automation, and this is an example of a level 4 automation would look like. So let's go ahead and discuss that. Okay, so let's say the first step in a workflow is the project identification. Okay, let's assume, okay, the organizations has identified the project. Then the next step is obviously data. So we do understand the importance of data, and we do understand your data will change, correct? I did give an example of what happened during the COVID, right? And this is where we use a dedicated tool for versioning a data. We call it as data version control. A tool that helps you to version a data. Can I throw one simple example? It's called DVC, which stands for data version control. Or if I use clouds like AWS, Azure, and GCP, they got their own tool to version your data. So then comes what? Data pre-processing step. So we do understand what is data pre-processing. It's all about cleaning your data, transforming your data. Here comes your data engineers or data scientists. They write a lot of code. A Python, for an example. And we do understand the importance of versioning your source code. This is where we bring code repositories. It can be, let's say it can be GitHub, Bitbucket, or any code repository that you want to use on different cloud platforms. And then comes a model building step. So this is where, again, your data scientists, they write a lot of scripts, a code, and a code has to be versioned. We do understand that a code that you write will definitely change tomorrow. So then comes a model training step. So in a model training step, this is where we take the data and we started training the machines. And here comes something called a feature stores. So what do you mean by feature stores? A feature stores are basically a schema repositories. So consider that. Let's talk about a features first of all. Let's say I have a voltage, a current, the bills, or maybe power. So let's say this is my data set, which actually helps me to train a machine learning model, which is going to helpful for me to predict what will be my electricity bills is going to look like for the next 6 months. Our voltage is a feature and current, the bills and powers, for an example. This could be a feature. But what is a feature store? A feature store is a schema repository, which maintains a schema of your features. So for an example, let's say with voltage, current, and bills, this can be a version 1 of my feature. And with voltage, bill, and powers and current, this can be a version 2 of my features. So basically, you can use feature stores in order to create a feature versions. And you can also transform your features if you want. A minimal transformation can be also done on a feature stores. Feature store is not a data repository. We don't store the data. We just store the information of your feature, a data type of your feature. So we fetched the right kind of a feature and the right kind of a data. Then we started building a machine learning model here. What happens at the end of the day, when you build the model, you get model artifacts. Model artifacts are which is inclusive of your machine learning model. So now you have your model artifact. You have built a model. Perfect. So now comes we integrate your model artifacts with model registries. So what is model registries? It's a dedicated tools that we can able to use it to go ahead and version your machine learning models, right? So if I want to name a one tool, I would say MLflow. It's a very famous tool. You should definitely must have in your resume if you're focusing into getting into AI industry. Then comes, let's say model registry would help you to version any different versions of models, for an example. So now you want to focus on the deployment. So now you want to go ahead and deploy it on your favorite infrastructure, maybe real-time, batch, or Dockers, Kubernetes, etc. So you go ahead and grab the best version of a model and you go ahead and deploy it, then you integrate it and you start operation in the production, right? So once you keep operating in a production, this is where we talk about traceability. So we need to monitor the complete infrastructure that you've built for your end-to-end automation, as well as you want to monitor the model in a production. And then comes, we are talking about automated retraining concept. So consider that once in every, now you, let's imagine you have deployed the first version of a model to the production where your customers can started using it. So what happens, maybe you have some drift, and maybe once in every 6 months, maybe you want to retrain your entire machine learning model with a new data, because your customers are coming with new data and you will be collecting all this new data. And again, you want to retrain this entire machine learning model once in every 6 months, once in every year, or maybe once in every month. It's up to the use case of your organization. And you want to redeploy the model to the production. So this is what exactly we're talking about in level 4 automations, where everything is automated. Everything, starting from picking a data, pre-processing it, training it, going ahead and deploying it. So then comes, we do have a feedback loop. So from this feedback loop, this is where you would be going ahead and collecting the new data from your customer. You go ahead and store it again. So you create the second version of data probably, and you retrain the second version of data and you redeploy it. So we do have something called automated quality gates as well here. So what do you mean by automated quality gates? I can have an automated quality gates at the time of deployment, as well as I can have an automated quality gates at the time of data pre-processing as well. So automated quality gates can help any organization to decide whether it's the best model can I deploy to the production. Every organization will have something called benchmark. So consider that here, if I'm training a regression model, I would keep, if my regression, I want my regression model, let's say a specific metrics that I'm looking forward. If my MSE score is 7, let's say if my MSE score is less than or equal to 7, if this condition is true, I want to go ahead and register my model to model registry. Otherwise, I will not register my model to model registry. If this condition is true, let's say if my MSE score is 4.5. So this 4.5 is something that I occupy at the time of training my machine learning model. So my MSE score is 4.5, which is lesser than equal to the benchmark that my organization has decided. Yes, it's true. It registers your first model to model registry. That means this model is an eligible model to deploy to the production. So that's how it's going to work. So this is about a level 4 architecture. But again, once you come down, if you go to level 3, level 2, you will be having a less automation, for an example, right? So saying that, so now let's move on to the next step, okay? So we are talking about different roles involved in the process of building and complete end-to-end automation here. So you might be coming from a data engineering, data science, software engineer. You might be a software tester, cloud architect. You have a lot of possible ways where you can be part of this operations, MLOps. So obviously, when I'm talking about developing a successful machine learning project, definitely involves varieties of experience and requires extreme collaboration among a team. So consider that it depends on an organization. So where you can see a different roles, how you can be part of an AI industry, right? So let's say here we are talking about, so maybe a data analyst, right? So let's say a data analyst is someone who works closely with, let's say, a business team, as well as, let's say we are talking about a product manager. The ultimate goal for data analyst to extract the insights from a user data. So he plays with the tools like SQL, Excel sheets, range of data visualization tools like Tableau and Power BI, right? So when we are talking about your data engineers, so data engineers are someone who makes sure the infrastructure to collect the data, to transform your data, etc. So your data engineers would be working with tools like ETL tools, Hadoop tools, and data engineers would be working with feature stores that I discussed, data versioning tools like DVC, etc. They would be working with that. And here is our dear data scientist. So data scientist is someone who builds a machine learning model, not an MLOps engineer, not a data engineer. So data scientist is someone who makes this machine learning model, who writes a huge code in Python, who does it. So data scientist builds a machine learning model, the model which will become part of final end product. So then comes, you can also see someone called research or applied scientist. You don't see this kind of a role in many organizations, but usually this research scientist, they would be working on cutting edge technologies, which organization works. Especially you'll see this kind of a roles in organizations like Meta, Google, Amazon, Apple, etc. So then comes, we are talking about an ML engineers or someone we call it as DevOps team. So we don't call it as DevOps engineers in AI industry, but usually we can say MLOps engineers or ML engineers basically. But what does this ML engineers does? So this ML engineers work will be overlapped with data engineers, and ML engineers mostly they will be focusing on taking the model which is trained by your data scientist and they go ahead and deploy this to the production. So ML engineers are basically deployment peoples, we can say. So then comes, you would be also seeing developers, we can say someone who takes everything and integrates and he builds an application, a front end, Android applications, everything. So then comes, we are talking about an MLOps engineers. MLOps engineers are someone who integrates everything and who builds this automation. This entire automation, the integration will be taken care by your MLOps engineers. So MLOps engineers are someone who builds this complete automation end to end, which integrates data, data scientists, ML engineers, everyone, and to finally take the model to deploy to the production. MLOps engineers also take care of an infrastructure, deploying the infrastructure, managing the infrastructure, and using that infrastructure to build, train, and deploy your models to the production again and again, the automation that I'm talking about. Okay, saying that, it's time, why don't we go ahead and explore the different flavors of tools that's available outside in the market, right? Let's get started. So as we're talking about, the world today runs on a cloud, and there are organizations, even though they're using a cloud, they use various different tools, right? So now, let's say we need a wide varieties of tools, right? It's like, okay, you go for a supermarket, what we do, if you go for a supermarket, you go ahead and pick the right things that you need. Maybe you need some groceries, maybe you need some vegetables, probably you need some plastic items, maybe you need some electronic gadgets, etc. You go ahead and pick what exactly you need, right? Yeah, so something like that. So here is a slide which explains the different flavors of tools that's available in the market, but I didn't specify all the tools, which gives an enough idea for you to understand the different flavors of tools. Let's say we need different tools for versioning your data, for experiment tracking, code versioning, model registries, model monitoring, etc. But ultimately the game is, okay, let me zoom it. So let's say we know that the workflow looks like this, right? The workflow would look like this. The first step in a workflow is data collection and labeling. So first we collect the data, then we do data exploration, so which is nothing but cleaning the data. Then comes, we go ahead and use the clean data and we build a machine learning model, right? So once we have a model, then we go ahead and focus on deploying this model to the production, right? That's the final step in a workflow. So in order to implement the steps, let's say we use various different tools. Let's say we start from development IDs. As an MLOps engineer, as a data scientist, or data engineer, and anyone who is going to be part of AI industry, you do use various different tools for write a script. It can be a Jupyter Notebooks or VS Code or Spider or PyCharm, etc. There are different tools that you use. For code versioning, or maybe for your infrastructure as a code that you need to version, we use various different code versioning tools. It can be GitHub, Bitbucket. You have different flavors that's outside in the market, right? So again, so as an MLOps engineers, you'd be also playing with code versioning tools. So then comes a data labeling tools is more specific to your data scientist, right? So consider that you want to teach a picture of a cat to your machine, and your machine should have a label called it's a cat. So basically for labeling your data. And here comes the data exploration and visualization tools. So because as a human beings, we are a visual beings, isn't it? So if I go ahead and share you a CSV file, which is around 30,000 data points you have, if I ask you to go ahead and extract the insight from it, you cannot. But if I display the same data in a visual format, a graph, right, something like that, we get better insight. So your data scientist uses various different data visualization tools like Matplotlib, Seaborn, Pandas, etc. to extract the insight from the data. So then comes, we are talking about feature engineering tools. right? So where you want to play with the features, you can use various different tools here, sklearn. And this particular slide, what you're seeing, it has both cloud-based tools, open source tools, and as well as commercial tools. Commercial tools are like subscription platforms. You pay a monthly subscription and you can use it. So for an example, feature tools, right? They're commercial tools. Feast is an open source tool that you can use it for feature engineering. And here comes your data scientist. He uses various different model training algorithms, let's say sklearn, PyTorch, XGBoost, TensorFlow, for building various different models. Classical machine learning models you want to build, or maybe you want to fine-tune a large language models, or you want to fine-tune any generative AI models. So he will be using various different algorithms. So then comes what? So he has a model, but data scientists want to evaluate by building a quick POC, a proof of concept, to ensure that his model works, it gets a good result. He go ahead and use different platforms like Jupyter, Streamlit to go ahead and temporarily deploy and check whether how the model works. So then comes, we have a tools for model debugging and visualization. So this is where your data scientist would be using a tools for debugging and visualizing models. He can use open source tools like TensorBoard, or commercial tools like Neptune.ai, or weights and biases, which is again a commercial tool. So then comes, we discussed about hyperparameter optimization. For a reason, we call him as a data scientist, right? So we use various different tools for hyperparameter optimization here. So then comes for experiment tracking. So this is where again, MLOps engineers, data scientists, data engineers also comes into the picture. So here we use various different experiment tracking tools. One famous tool which I'm mentioning is MLflow, where you can register your experiments and you can compare between, so let's say thousands of experiments that you have, and you can pick the best model that you can use it to deploy to the production. So there are different tools. You can use Neptune.ai, you can use TensorBoard, which is again open source tool. So then we are talking about a tool for packing your machine learning model. Let's say I want to deploy the model so to the production. So that means I need to pack the model. So there are different ways to pack a model. So let's say you can pack your model in the form of MLflow, or TensorFlow, or PyTorch, or ONNX, or are you using open source tool, you can go for Kubeflow. So then comes, once you pack your model, what's the next step? We need to go ahead and serve your model to the production. So now, in order to deploy the model to the production, there are more than one way to deploy it, but here I specified few. So let's say you want to deploy the model on AWS SageMaker, or Azure ML Studio, Vertex AI, Docker, Kubernetes, different options, right? Or you want to use commercial tools like Bento ML, etc. So then comes a workflow orchestration. So this is where your MLOps engineers comes into the picture. So consider that I want to orchestrate my complete workflow, which I'm talking about an end-to-end automation, right? Which I want to build. So this is where you have an option to pick various different tools. You can use Apache Airflow, Kubeflow, ZenML, something on AWS, Azure GCP. They have their own way to orchestrate your pipeline. Orchestration is nothing but a step-by-step approach, how you can able to automate everything, starting from picking a data, cleaning it, training it, evaluating it, and going ahead and deploying it to the production. Again, scheduling the pipeline accordingly. Once in every 6 months, automatically the pipeline runs and it produces the second version of a model. So then we discussed about the importance of versioning your data. So this is where tools like DVC, Git large files, and there are a lot of tools that you can able to use it for versioning your data. So then we discussed about the importance of versioning your models. So we use model registries or dedicated tools for versioning your models. You can use MLflow. That's a very famous tool. SageMaker in AWS, they have their own model registry. Azure ML, they have their own model registry. Vertex AI, or any other tools that we're talking about, they have their own model registries. So then comes for model monitoring. Let's say now you have deployed the model. Now you want to monitor this model in a production. So that means you need to use various different tools. You can use SDKs, which is provided by cloud, or you can use open source tools, a pretty much famous tool, which is called Evidently AI, which I didn't mention here, but you can use other tools like Celdon, Fiddler, Vitra, etc. for that. And we discussed about feature stores, right? So feature stores are schema repositories for your features, and you can use various different feature stores. Every cloud today, they have their own feature store. Or you don't want to use a cloud, you can go for open source feature stores like Feast, for an example. So these are the various different flavors that is available in the market that you can pick. Even there are more tools. This gets an idea. So what are the different flavors of tools that you might use? So consider that. So today I'm talking about your future into AI as an MLOps engineer for the next 10 to 15 years. Maybe in some point of time, you might be working in a lead positions in MLOps, like MLOps lead, architect, specialist kind of a roles. So who do you think in your organization who will be picking a right tool? An architects? Yeah. So how does any person who is in a lead position would pick the tool, right? There are various different ways. Whether you go for open source tools or whether you go for closed source tools, right? That's the first thing. So obviously we do understand that open source tools are always free, and obviously they are easy to integrate with your MLOps tools, right? There's no doubt about it. But the only problem is if you have very few developers who is aware about your open source tools, then it would be a problem. So then comes we are talking about platform versus specific tools. Either you can go for a cloud-based tools and you know that every cloud follows a business model like pay as you go, or you can go for commercial tools. The commercial tools are subscription platforms. You go ahead and pay a subscription every month to use a tool, right? So then comes, you might be picking a tool where you have a model and production environment monitoring setup. So let's say if you're picking a tool for your organization, make sure it has a model monitoring capability and production environment monitoring capability. The complete infrastructure that you have for delivering your models to the production at the end-to-end setup for training, right? Data preparation, etc. So, and then comes we are talking about so making sure that you have a tool for monitoring your model and monitoring your environment, making sure that, okay, you have a bugs are documented and addressed in the meantime. And again, you have some security and compliances concern can be addressed as well. So then comes, we are talking about model templating and cataloging. So when I'm talking about MLOps, it's all about a templated workflow. So this is where it plays very important role. So consider that tomorrow when you're going to work as an MLOps engineer, for an example, so maybe you work with various different projects, but the question is, are you going to reinvent a wheel again and again and again for every different projects that you're going to work for various different clients? Definitely not. No one would like to reinvent a wheel. So this is where MLOps comes into picture. Okay, let's assume that you have delivered a one successful project and where you have templated it. And a template for a reason, so you can able to make some minimal changes onto that particular template and you can reuse the template again and again to replicate a success. Right? So that's where model templating and cataloging plays very important role. So then comes, we are talking about model training, tuning, and drift management. So we do understand that. So MLOps is all about building an automation. So does a tool that you're picking, maybe on AWS, Azure, GCP, or any open source tool that you pick, so does the tool help you in building an automation? Automation for automated training, retraining, and drift management. 1 second, folks. So can you able to build an end-to-end automation? That's a question. Then comes a pipeline management. So consider that. When I'm talking about MLOps, it's all about collaboration between various different folks here. So you might be having a data engineers, data scientists, ML engineers, right? So testing team, your MLOps engineers at the end of the day, right? So do you have a system where you can able to collaborate and work with everyone? So consider that we are talking about, let's say you're running a pipeline. Maybe your pipeline got failed. So do you have a system where you can able to automatically trigger an updates and notification for your data scientist saying that your pipeline got failed, for an example, right? So then comes we are talking about collaboration and communication capabilities. At the end of the day, everyone will be collaborating together. So, and making sure that you document your workflows, right? Or maybe, let's say you're integrating a project management tools like Jira, Slack, for an example. So where you can communicate and work together, for an example, right? So these are some key features of MLOps tools when you're going to pick, right? So now let's talk about MLOps on cloud platforms, right? So here we will be covering the 3 major cloud platforms in this particular program: AWS, Azure, and GCP. So, and why cloud platform? And we do understand, so the world runs on a cloud. And especially we are talking about these 3 major cloud platforms, which is AWS, Azure, and GCP. So because they occupy majority of share in the world, right? So obviously that means most of the organizations, they run their machine learning workflows on these 3 cloud platforms. So in our MLOps specialization program, so we do cover MLOps and DevOps tools on all those 3 cloud platforms, which is AWS, Azure, and GCP. So not limited to cloud platforms, open source tools as well. Because there are organizations, even though they use cloud, they use open source tools like Docker, Kubernetes, MLflow, Kubeflow, ZenML, DVC, etc. And I have seen organizations, they use multi-cloud, right? I have seen organizations, they use Azure DevOps where they run their pipelines and they deploy the models to AWS, for an example, right? So that means I say it's a 360-degree view of MLOps. I mean, professionals after upskilling in MLOps, they could literally work for any organizations. Whether an organization is looking for AWS, here we go, you have a skill. Our Azure, here we go, you have a skill. Our Azure, our GCP, our open source tools. So that's how it's going to work. You get 360-degree view of MLOps. Your probability of reaching your destination to occupy or to rule this world of AI will be made easier. Okay, saying that, so now let's talk about the different tools that we will be exploring throughout this program. So first, let's get started with Git-based tools, right? So we do understand the importance of Git. We use Git-based tools like it can be GitHub or Azure repos or any cloud-based repositories. It can be Bitbucket, or we are talking about other cloud-native tools like Google Cloud repositories or AWS Code Commit. So these tools are temporarily disabled for new customers. But yeah, there are different tools that's available where you can explore for versioning your source code, your infrastructure code, your ML, etc. So then we are talking about something called CI/CD. I might have referred to this word previously. So what is this CI and CD? So which I'm talking about. So continuous integration and continuous deployment. So what does that mean, right? So CI/CD is a practice that we use in any software industry to deliver a new version of a software to the production. So basically, the CI/CD practices improves basically a software delivery and improves the software development lifecycle. So let's try to understand what is this CI/CD pipelines, how does it works, and then we will go ahead and understand how the MLOps pipelines would also work with integration of CI/CD. Okay, so here let's consider that you have a developer. Okay, so you have a dear developer, let's say you make some changes to the code and he pushed the code to a code repository. And here is an automation. CI/CD is built for an automation. So it understands that your developer has made some changes. He has pushed the code to a repository and automatically it will started triggering a build. So what do you mean by build? So consider that there is a Java developer who written a code in Java. He pushed the code to a repository and first step in a workflow, we build a software. So basically the ultimate goal for us to produce maybe a jar files, a final artifact which we can able to go ahead and deploy it to the production, right? So consider that here we go ahead and build and we also notify because we are talking about your DevOps engineers. So we need to notify that, okay, your build process has succeeded, or if it is failed, we say that it's failed. That means he can come and fix it. And once your build is completed, then we go ahead and run some test. Because when you have a software or when you have a machine learning model, testing your model or a software is really important to make sure that it attains and qualifies the quality that you need. And if all your testings has been done, we notify it succeeded, or if it is fails, we notify that your testing got failed. So then we focus on going ahead and delivering it to the production. We go ahead and deploy your software to your web application, web server, etc. For an example, let's throw a simple example here. Okay, let's assume here is a software in a production view. Consider that we are talking about an e-commerce website. It can be Amazon.com itself. Let's say an Amazon.com has a green color button which says pay now. Okay. And so basically, you know that green is not so much attractive. There are customers who complain, okay, I don't like the green color button which says pay now. Can you please go ahead and change it? Can you please change the color of green? So, and here comes, based on a feedback, your developers changing the color of a button from green to red. And here is our CI/CD setup. I'm using code pipelines on top of AWS. So, and I'm using GitHub as my code repository. And here the developer pushed the code to a dev branch that he has. So I have two different branches for two different environments. So I push the code to a dev branch, and here I have a tools where it will automatically understand that your developer has pushed the code, he has committed a code, and it will automatically start building your software. So once the building of a software is done, we generate an artifacts. Let's say jar file for an example. And once the artifacts are available, in the next step, I go ahead and deploy it. Maybe let's say I'm talking about simple web application. I go ahead and deploy it to a web server. So initially, I go ahead and deploy my application to my dev environment. As I mentioned, a dev or staging environment, which is an exact copy of a production. So maybe here I go ahead and do the further testing. And here comes your internal team. They go ahead and do a further testing. They check the functionality of a button. They check whether can we click it, the functionality is working or not. If all the test and if they're really satisfied with that, in the next step, we go ahead and deploy the same exact feature to the production. So now the production is also served with a red color pay now button. So that's how the CI/CD works. And here is an example of a CI/CD in terms of MLOps pipeline. Again, we'll start from your data scientist here. Let's say he makes some changes to the Python code of way he want to build a model. He commits and push the code to a code repository, and automatically, let's say once he pushed the code to a code repository, your pipelines understands that. Okay, your developer our data scientist has made some changes to the code and it triggers your pipeline. Everything runs automatically here. The first step in a workflow, what we call it as feature engineering. Otherwise, a data preparation step that I'm talking about, right? I do the data preparation right now. Once the data preparation is done, what we do next? The next step, I go ahead and train the machine learning model. I teach the data. Once my training is done, in a third step, I go ahead and evaluate my machine learning model. Testing. And as part of a model evaluation, as I mentioned, here I go ahead and extract various different metrics. Let's say I calculate MSE score. Let's say I'm training a regression model, MSE score or RMSE score. So what is this metrics anyway? So metrics are basically a numbers which actually helps in any organization or a data scientist to decide whether it is a best model, can we go ahead and deploy it to the production. Every metrics that he calculates has some benchmark which is decided by a team. Let's assume, as I mentioned, so if my MSE score has to be 7, less than or equal to 7. That's the benchmark your organization has decided. And in a step number 4, this is where we have a condition step. Otherwise, I did mention about quality gate. Do you remember that? So this is where I have a condition. If my MSC score is less than or equal to 7, if this condition is true, then I go ahead and register my first version of a model to model registry. So this is where I have a model registry. So this condition has to be satisfied. If this condition satisfy, I go ahead and register my first version of a model to the model registry. So now I have my model in a model registry. Then comes the next step in a workflow. Let's say I want to Dockerize this model. I go ahead and Dockerize it. Then I go ahead and deploy it. So here again, I have a same setup. First, I go ahead and deploy it to, let's say, dev or staging environment. And here comes your internal team. Maybe MLOps engineers or data scientists, they go ahead and do the further testing. And if they're really satisfied with that, then they go ahead and deploy the same version 1 of a model to the production. And this is where your end users can able to start consuming a model. And I go ahead also implement a model monitoring tools, which completely monitors the model in a production and keeps on monitoring and ensures that your model is clean, and it also notifies a drift in your data, etc. So this is how your MLOps pipelines would look like. Now, let's also talk about what is, okay, one second. So let's also talk about what is this LLM ops pipeline. Let's say when I'm talking about LLM ops, it's all about, we're talking about delivering your large language models to the production. LLM ops is nothing much different than ML ops. It's all about ML ops for LLMs. So what do you mean by that? How do you adapt your ML ops methods to deliver a large language model to the production? Let's try to understand what's the difference here. Let's say you want to deliver any kind of your large language model. Let's say it can be a Llama based model, AI21 Labs, Stability AI, Anthropic models, DeepSeek, etc. Let's say you want to fine tune it, then you want to go ahead and deliver it. So what's additional part here? That's what exactly we'll be focusing. So the first step in a workflow, nothing much changes. The first step is basically data preparation and versioning. Exactly same. Then comes here, we are talking about supervised fine tuning. So here we fine tune the model rather than training the complete model from scratch, because you don't have a budget to train the model from scratch. We know the numbers. You know that DeepSeek itself cost around $6 million to train the model, which they claim is the most cheapest and cost affordable model ever built. And again, So let's say if we talk about Google Gemini cost around more than $100 million to build. You cannot build the model from the scratch. Yes, you can, but if you have a budget and infrastructure. But let's say here we are talking about fine tuning, using an existing model and fine tune that model with a new data. And again, we have the same artifacts. Let's say if you're going to pick a Llama model from Meta and you produce your own after you fine tune it, you produce your own version of a Llama model. Maybe I would say Llama version 1 Citron. So this is my own version of a model. I go ahead and use the same model registries where I can version these models. Then I go ahead and execute the pipeline. So I want to go ahead and deploy this Llama model to the production. So I want to go ahead and deploy it to the huge GPU based instances, maybe H100, H200 GPU instances. So then comes the two additional part that is not there is prompt engineering and predictions and responsible AI. So prompt engineering, prompting is all about the input that you feed to your AI. So that means it can able to answer based on your input. It's a question that you feed, right? So then comes, we are talking about responsible AI. It's all about building a responsible Gen AI application for your customers. And this is where your customer and AI also comes in picture. We do understand in the world of Gen AI, a lot of things can go wrong, right? Isn't it? Consider that we are talking about building a responsible AI innovation here. So consider that your customers can able to misuse your AI, especially this generative AI, correct? Because there are chances that your customers could able to generate an harmful content. It can be harmful text, pictures, images. It can be anything that can be harmful for someone else, right? And this is where a responsible AI comes into picture. A responsible AI acts like a filter. So consider that if your customer is inputting some harmful content to be generated and you responsibly understand that user is trying to generate an harmful content and you responsibly replace back saying that I cannot assist with that request, right? I cannot assist with that request basically. So again, your AI could also generate some harmful content and where your responsible AI could also filter that particular harmful content. This is where responsible AI also plays very important role. Okay, saying that, so this is how your LLMOps pipelines would look like. Saying that, so now let's focus on the CI/CD tools that we cover in this particular program. So starting from AWS. So we do cover the complete DevOps tools on top of AWS, starting from AWS code pipelines, understanding code build, code commit, or code deploy, etc. So understanding the complete Azure DevOps tools, the complete Azure DevOps suite. So starting from understanding Azure repos, Azure pipelines, Azure test plans, Azure boards, a lot of things that you can learn. Then comes Google Cloud Platform. The Google also has their own set of DevOps tools, starting from Cloud Run, Cloud Build, Cloud Deploy, or Google Cloud repositories. So not limited to the cloud-based tools, we'll be also exploring open source tools like GitHub Actions, including Jenkins as well. So saying that, then comes understanding Dockers and Kubernetes. So we do understand the world today uses Dockers and Kubernetes. And again, a lot of the workloads today runs on Dockers and Kubernetes. So we will be exploring Dockers from the scratch and we will be exploring Kubernetes from the scratch. That means the Dockers and Kubernetes for MLOps here. So not limited to Dockers and Kubernetes and open source, but today we are talking about a cloud-based Kubernetes services. So we'll be exploring Amazon EKS, which stands for Elastic Kubernetes Service, is a Kubernetes service on top of AWS. Azure has their own Kubernetes service. They call it as Azure Kubernetes Service. And Google has Google Kubernetes Engine. So we will be exploring both, where you will be learning how to build and deploy your models into the Kubernetes infrastructure, etc. And obviously, so not limited to the cloud and not limited to the not limited to the various different clouds. And here we are talking about an open source tools that we will be covering in MLOps, starting from data versioning tools that we'll be exploring, DVC, hands-on. Yes, then comes Git large files. We are talking about feature stores, and here we'll be exploring the open source feature store, which is a feast, which is pretty much famous that you must know. Then comes, we discussed about workflow orchestration tools, right? So we'll be exploring tools like Kubeflow, Apache Airflow, ZenML, Metaflow, MLRun, right? Kedros, a CML. There's a lot of workflow orchestration tools, including Argo workflow. And then comes, as part of an open source tool, we'll be exploring MLflow from the scratch, where you'll be understanding how to deploy the infrastructure for MLflow and how to register your models, experiments, etc. Then comes for the infrastructure as a code for the open source tool, we'll be exploring Terraform here. So then comes, I did discuss about pretty much a famous tool that's outside in the market, for monitoring your ML models, evidently AI, for an example, right? So then comes, we are talking about a cloud-based MLOps tools. So where we spend a lot of time. So on top of AWS, we'll be exploring Amazon SageMaker. So where you learn how to build a level 4 architecture projects. And Azure, we'll be exploring Azure ML Workspace, where you'll be learning level 4 architecture project. And GCP, they have their own tool. They call it as Vertex AI. And where you'll be exploring the level 4 architecture projects on top of it. And for monitoring your models and infrastructures, every cloud platform has their own SDKs today. We'll be also exploring those SDKs on top of various different clouds like AWS, Azure, and GCP. And not limited to, let's say, cloud or open source tools here. I would like to also give you a taste of a commercial MLOps tools that's outside of the market. So I'm talking about a subscription-based platforms. We'll be also exploring the tools like Isguazio, Olahai, Domino Data Labs, weights and biases. So our Upswork are, let's say, Tecton or Databricks for feature stores, etc. So this would be the commercial tools that we're talking about, right? So then comes, we will be exploring the post-deployment challenges. What happens after you deploy the model to the production? So that's where, okay, now the models has been deployed to the production, whether the job is done, definitely not. The actual job starts after you're deploying the model to the production, right? So this is where we'll be exploring the post-deployment challenges related to software engineering, ML related, and what challenges that you face when you're deploying the models to the edge, mobile phones, IoT devices, etc. Right? So this is what it takes to master MLOps, the kind of tools that we're exploring, right? So saying that, so here, why don't we go ahead and have some live demo? So here I have already built an end-to-end ML pipeline. So I will show you a console of Amazon SageMaker Studio, and where I will be showing my pipeline, the orchestration, and I will show you how I go ahead and deploy my model to the production, the manual approval process, etc. that I'm talking about, right? So let's get started. So please make sure that you stay till end of this program. So once we are done with demo, so the next thing that we're going to discuss, the career opportunities of yours, how it's going to be in the world of MLOps, right? So make sure you stay till end of this program. So now let's go ahead and have a quick demo on top of AWS. So here I have arranged a demo on AWS, but in this program, so you will be experimenting, you will be playing with me. That means whatever I do on my screen, you'll be doing it on your screen, especially during the program. So let's get started with a quick demo here I have arranged. So let's get into the project right now. Just give me a second. Yeah. So here we go. Yeah. Let me just bring my screen. Okay, so here we go. Like this is your Amazon SageMaker Studio console. So which AWS has, they call it as Amazon SageMaker Studio. And when we're talking about Azure or GCP, Azure has their own platform. They call it as Azure Machine Learning Studio. In GCP, they have Vertex AI. They have a similar capabilities, right? So here, Amazon SageMaker Studio is a platform which is integrated with everything that organization needs to build an end-to-end ML pipelines. Are you interested to get started with, let's say, large language models or GenAI workflow, GenAI use cases? They got a model, starting from whether you want to use DeepSeek models, Meta-based Llama models. So they got all the models for you, right? And here, let me just quickly go to the projects. So here you can able to see there is a one project that I built, which is called Citron ML test, for an example. So this is where you can able to see the end-to-end ML pipelines that I have built so far. And here you can see I have repositories, pipelines, experiments, model groups, endpoints, etc. So this is where you can see there is something called pipelines. So this is where you will notice that an end-to-end ML pipeline that I've built will be executing. It's a level 4 architecture project that I've built. As I mentioned, a level 4 architecture project, which is what we're talking about, an automated retraining pipelines. Okay. So here, so let me just show you the architecture that I used in order to build this entire orchestration, right? It's a huge work that goes into building this end-to-end architecture. So this is the architecture that I've used in order to build this end-to-end ML pipeline. Yeah, you can see it's huge, right? Obviously, it took probably an 8 hours during our program to build this architecture. So this is what exactly we call it as level 4 architecture. I'm not going to explain this architecture as of right now, but I will just explain this architecture in a very simple form. So this particular architecture has 3 different pipelines in it. One pipeline, let's say it go ahead and deploys the infrastructure. Let me just write it down here. So let's say I have 3 pipelines, one pipeline which actually deploys the infrastructure that needed for your team to go ahead and build, train, and deploy a machine learning model. I have a second pipeline which actually builds, trains, and registers your model to model registry. As we discussed in a model, in order to register a model to model registry, we discussed about this quality gate. If my MSE score is less than or equal to 7. So yeah, if it is, it go ahead and registers your first version of a model to the production. Then comes, I have a third pipeline, which actually deploys your model to the production, for an example. It's 3 different pipelines. So what you are seeing in this particular architecture. So basically the first pipeline is over here, which actually deploys your infrastructure. And here is your second pipeline, which actually builds, trains, and registers your model to model registry. And here is your third pipeline. Third pipeline is called deploy pipeline, which will grab the latest version of a model in a model registry. I might have version 1, version 2, version 3 is latest, let's assume. It go ahead and deploys the model to a real-time endpoint in SageMaker, right? So that's what exactly this architecture is. But here I will show you the orchestration that I built, right? So now let's get started. So here you can see I have a pipeline section. I have one pipeline which was executed previously. Let me just go to this pipeline. You can see I have one pipeline. There's a random name to it. If I go inside this particular pipeline, so this is the orchestration that I'm talking about. So this specific orchestration that you can see, this comes post deployment of my infrastructure. So this is basically the second pipeline that I'm showing. So the second pipeline, which actually, which is here, you can see, let me just zoom it. So you can see this is what exactly I do in a second pipeline. What's the second pipeline? As I mentioned, it actually takes the data, it will do the cleaning, pre-processing, trains the model, and registers the model to model registry. The first step, what I do is go ahead and pre-process my data. Then I go ahead and train my model. I evaluate my model. Then I go ahead and register my best model after evaluation of version 1 or version 2 it is to a model registry. So that's what exactly you can see it here. So the first step you can see in this orchestration is basically pre-process your data. So what use case that I've built here? So basically here I'm trying to predict an age of a seafood data. It's called abalone. So use cases can be anything, doesn't matter. So consider that whether tomorrow you would be working for an organization where you might be working with the banking sector, financial sector, health sector. This pipelines that I built, which is level 4 architecture project, which fits in any kind of a use case. So whether it's all about the template, as I mentioned, right? So you replace the data with your own organization data, you replace the infrastructure however you need, the pipeline works like a magic. So basically here is a use case that I'm talking about. So where I have trained an abalone model. So basically it's a seafood. I mean, in case if you're a seafood lover, probably you might have seen it. An abalone is a seafood where you have a meat within the shells, which we can able to eat. So basically the use case is to predict an age of an abalone. So based on an age of an abalone, the price is decided in a market. So that's what exactly you can see here. The first step is basically a data pre-processing. This is where your data is being feeded and where I clean and prepare the data. The next step in a workflow, so this is where my model gets trained. So this is where I train my abalone model. So then comes in a model evaluation step. You can see this is where I evaluate my machine learning model. So this is where your data scientist has pre-configured. Every step here, every orchestration here runs automatically. No one runs it manually because it's a level 4 architecture project. So here I go ahead and automate. So here your data scientist might have pre-configured to calculate a metrics like MSE, RMSE. It depends on the use case. Classification, let's say we're talking about precision recall. There are different metrics you want to calculate. So then comes, we are talking about, let's say, check MSC abalone evaluation. So this is what exactly I discussed about a quality gate. So this is where I have a condition. If my MSC score is less than or equal to 7, if this condition satisfies, I mean, if it is true, it will go ahead and registers your model to model registry. So which is this, you can see. So once the model is registered to a model registry, so then you can go ahead and deploy this model to the production at various different stages that you're looking forward. So now let's go back to your pipeline. So now if I go back to my pipeline here, let's go back. So, and here we can able to access a lot of other details. 1 second. Yep. So here I have pipelines, and here you can see experiments. So this is where your data scientist experiments will be landed. As I discussed, your data scientist conducts what we call it as an experiments. So then comes, we have model groups. So this is what I call it as model registry otherwise. So this is where each and every time when your pipeline runs, let's say I've scheduled my pipeline accordingly, so where it runs once in every 6 months, once in every year, and it automatically produces the second version of a model, and it will go ahead and register all the different versions of a models into this model registry. So now if I go inside this model registry, so now let me just pick the different model registry, so where I can show you a different versions of models in there. Yeah. So now let me go to this specific model registry. You can able to see that so far I have 3 different versions of models I have already trained. The first version, the second version, the third version. You can see the first version of a model is already approved. It has been deployed to the production. Second version of a model, maybe it has trained some point of a time, and it might be already approved and deployed in a production. So now you can see I have third version of a model, which is actually pending for my approval process. As I mentioned, I need an additional control over where I want to deploy this model to the production. I have version 3 of my model. I can go ahead and approve it. I can test it. If I satisfied with that, I can go ahead and approve it and deploy it to the production. So you can see already my first version of a model is deployed 4 months ago. The second version I just deployed 2 hours ago, and I have my the third version of a model which has been trained and yet to be deployed. So now let me just show you quickly how I can go ahead and deploy this model to the production. If I go to version 3 here, right? So let's say once your data scientist trains a machine learning model, he wants to monitor a lot of different metrics in order to take a decision, whether it's a best model, can I go ahead and register this to production or not? So here I'm in a version 3 of this model. So here I can go ahead and check a various different metrics of this model. So here I have a training step. At the time of I'm training the model, how does the quality of a model looks like? So here I have a metrics, which I'm using an RMSE metrics, where I can go ahead and check. And if I'm really satisfied with that, I can take a further decision. And here I have a lot of other things. The hyperparameters that I use, this hyperparameters will be configured by your data scientist. So the hyperparameters that are used at the time of you training a model. This hyperparameters might change for different versions of models you might train in case he wants it. So then comes, if I go to my evaluation steps, so far I don't have any evaluation metrics, but if I go to my deployment stage, here you can see it says pending approval. That means this model yet to be approved to deploy to the production. And if I scroll down here, you can see the kind of machines that I would be using, a CPU-based machine that I would be using to deploy this model to the production. All I need to do, if I want to deploy this model to the production, I can click on this pending model approval. I get 3 different options. Either I can go ahead and select approval if everything is okay, if the quality of a model is okay, or if I don't like it, I can simply go ahead and reject it, right? So I can simply go ahead and click this approval button. And here I can go ahead and type an additional message. Maybe I'm a senior data scientist or MLOps engineer, someone I am going and reviewing the model. So here I can go ahead and tell, okay, all test, okay, some meaningful message. And then I can simply go ahead and click save button. So once I click save, this model has been, the status has been approved. That means it has been now, it will start deploying to the production. So once the model is getting deployed to the production, under towards left side navigation panel under endpoints, you will see this model will get deployed to the production in some time, right? So that's how this end-to-end ML pipelines work. So far, the goal of and MLOps engineers would be building these 3 pipelines. So they will be working with an ML or JSON, a minimal of Python to go ahead and build these 3 different pipelines. So executing, managing these pipelines will be taken care by an MLOps engineers, and where your data scientist will be working inside this particular, let's say the pipelines. So that means you will be collaborating with MLOps engineers, data scientists. Your data scientist will be focusing on building a models, writing a lot of Python code. And as an MLOps engineer, you'll be focusing on the deployment of an infrastructure, writing an ML script. But you would be also working with a very, very minimal Python here. But you don't need an expertise like a data scientist here, right? So that's how it works. So saying this, we will be building a similar and end-to-end level 4 architecture projects and all the 3 clouds, not limited to level 4, level 3, level 2 architectures will be also built in our program. So saying this, so now let's really focus on how does your career opportunities might look like in MLOps. So we do understand, so where MLOps really fits in and where you will be also really fits in, but how you can able to make your career into MLOps. See, consider that you might be coming from a DevOps engineer, software testing, or maybe a cloud background. You might be a software development. Each and every folks has different advantage here, right? But again, what everyone we think here, obviously we are talking about AI everywhere. And again, so we fear of AI and we want to make sure, let's say if you're doing your career transition into the different industry, you want to make sure that it is AI proof, isn't it? Yes, obviously here we are talking about a field of MLOps, which is machine learning operations. It's a part of AI industry, right? So definitely what we are discussing about, let's say, this is the latest quote, which I really, really like from Bill Gates. So it just made 3 months ago, I believe 1.5 to 2 months ago. It's basically from the late show from Stephen. So you can go ahead and check it. It's available on the internet. So Bill Gates just made a quote. So what Bill Gates said, AI is the only technology that has no limits. AI is the only technology which has no limits. What do you mean by that? See, consider that we are talking about various different software industries, and every time we fear about stagnation and where sometimes you get saturated, isn't it? So let's say we are talking about industries where, let's say we are talking about DevOps industry. DevOps is everywhere today, right? And again, we are talking about any software development. Today, AI is good at building a software, writing the code. There's no doubt about it, right? But the question is, so if you are being a creator of AI, right? So you cannot be replaced at the end of the day because you are someone who is creating an AI. That means you are an MLOps engineer, someone who is being a part of creating an AI. AI cannot replace the creators, right? At the end of the day, you are the one someone is creating. So when I'm talking about this specific code, AI is the only technology which has no limits. AI is not the term that we are discussing today. AI is there last 5 years ago, last 10 years ago, it's there last 15 years ago. We talked about all these famous technologies, right? We talked about blockchains, cryptocurrencies, and I mean, blockchains. We're not talking much about it. So we're talking about IoT, other technologies, and other software industries, they're stagnating. But AI is taking a different phases in each and every day. Like, so let's say last 10 years ago, we're talking about building a traditional models. And today we are talking about building generative AI models, right? So tomorrow we talk about AGIs. Tomorrow we talk about ASIs, right? Etc. But it can be any kind of a models, a classical machine learning model, a generative AI model. It can be AGIs. They need someone, an automation person behind it who can able to help them in delivering this AI to the production. It can be any kind of an AI. That's where MLOps really comes into the picture. So who can be part of MLOps? So you can be a data scientist, you can be a data engineer, a data analyst, you might be a researcher, applied scientist, you might be ML engineer, DevOps engineer, or aspiring MLOps professional and enthusiast. Or you are machine learning professional who want to learn how to deploy the model to the production, or anyone who is having a skills on AWS, Azure, GCP, or Docker and Kubernetes, right? MLflow, Feast, or most importantly, and any individual who is having an interest to get into AI. So you could be the person, a perfect fit for MLOps. The only prerequisite is if you have a good understanding of a software and IT industry, you are really fit to get started. The only prerequisite is that. And again, few people ask, okay, do I need to have a programming skill sets? Do I need to learn how to build a model? Definitely not. You're not a data scientist. You don't build models here. You take care of an automation. You build an end-to-end automation to deliver a model to the production. That doesn't